Okay, let us proceed with the last 4 problems for your keys and couplings. Now, solve naman natin yung pagdating ng couplings. Okay, so problem number 1 for couplings. 2 shafts are connected by a flange coupling. The coupling is secured by 6 bolts. So you are given 6 bolts, 20 millimeter in diameter, on a pitch circle of 150 millimeter. Ibig sabihin, pitch circle, that is the bolt circle. If the torque is 120 Newton meter is applied, find the shear stress on the bolts. Now, for the shear stress on the bolts, tinitignan mo dyan yung affected lang naman niya. So, force over area. Force over area. Diba ang force is yung formula natin, that is torque. Twice ng torque over the affected area. Ano ba affected area dyan? Of the bolts. So, that is twice of the torque applied divided by yung number of bolts na meron ka. Number of bolts times yung area ng bolt, pi over 4, d squared ng bolt, tapos multiplied by diameter ng bolt circle. Yan. Ay, hinihika ako So, the stress will be twice, tapos dapat ito naging Newton millimeter. So, that is 120,000. Kasi isang metro is 1,000 millimeter. Newton millimeter. Tapos, number of volts, 6 volts, pi over 4, times d squared. Ano ba yung diameter of the bolt? That is 20 millimeter squared. Tapos yung bolt circle mo is 150 mm. Ano bang hinihinging unit dyan? Eh, wala naman sinabi na hinihinging unit. Ibig sabihin, Newton per millimeter squared. Okay? So, the unit will be cancel to. Okay? So, 2 times 120,000 divided by 6 times pi over 4. Multiply mo ng 20 squared times 150. The answer will be 0.85 Newton per millimeter squared or 0.85, 0.88 on the bolts, on the bolts. 8488. 8488 MPa, approximately 0.85 MPa. Yan. Okay, so we solved problem number 1. So let's go with problem number 2. For problem number 2, medyo mahaba to A flange coupling has an outside diameter. Ito yung OD that connects two 40 millimeter shafts. Ito yung diameter of the shaft. There are four 16 millimeter bolts on a 140 millimeter bolt circle. The radial flange thickness is 20 mm. If the torsional stress on the shaft is not to exceed 26 MPa, 26 MPa, determine the shear stress in the bolts if uniformly distributed. Okay, so given ka dyan ng shear stress ng shaft equal to 16 torque over pi d cube. Hindi naman sinabi dyan kung hollow, so that is solid shaft. So, ang hahanapin mong una is torque. Okay? Pero i-reform na lang natin ng ganito yung torque. Turuan ko kayo ng isa pang technique na pag-solve. Okay? Torque will be equal to yung sa shaft, yung S ng shaft, shear stress of the shaft, multiply mo ng pi times d cube. Diameter of the shaft. Divide mo ng 16. Okay? Meron kang formula number 1. Anong hinahanap natin dyan? The shear stress on the bolts. The shear stress on the bolts is given by this formula. Force over area. Okay? And the force over area, pag sinimplify mo, that is twice nung area. Ano ba yung area? Number of bolts times pi over 4 times d squared ng bolts times diameter ng bolt circle. Ngayon yung torque, ayun no. So, pagsama-samahin natin, okay? Shear stress is equal to twice ng yun nanditong formula para isang pindutan sa calculator. Shaft times pi times d cube. Okay, diameter ng shaft yan. Divide mo ng 16. Okay? And then, i-divide mo ng number of bolts. Ang dami, di ba? Times pi over 4. Pero I assure you, kasi sa calcu yan. Times diameter ng bolt. Tapos, dBT. Sa mga manok. 2 times yung shear stress on the shaft. The shear stress on the shaft is, binigay ba dyan? 26 MPa. So, 26 Newton per millimeter squared. Okay? Times pi times yung d cube. D cube is diameter of the shaft 40 mm. Divided by 16. Number of the bolts, 4. Multiplied by pi over 4 times diameter of the bolt is 16 mm. Nakalagay doon kanina. Squared. Check natin kung tama. Ayun, 416 mm. Tapos the bolt circle. Ito na yung tamang pag-solve ha. Ganito ang gayahin nyo yun sa akin. Para hindi kayo nililito. So, bolt circle is 140 mm. Ganito rin dapat kayo mag-solve pagdating ng board exam. Ako yan, kinakalkyo ko lang yan. So, pindutin natin sa calculator. Isang pindutan lang to. Twice, okay? Huwag nyo lilituin ang sarili nyo. So, 26 times, shift pi times 40. Cube to ha, cube, hindi squared to, cube. Ayun o, cube yan. Cube, okay? Divide by 16. Divide by pi over 4 volts. Tama? Cancel to. Cancel to. E di 16 squared times 140 shift and pi. The answer will be 5.8036 MPa. 5.8036 MPa. Diba isang pindutan lang? Ayun, isang input, isang pindot, ayun na kagad. Ganun lang yung transition niya. So, papalit-palitan mo lang, pagsasama-samahin mo. Ngayon, pag hindi same ang unit, kailangan simplify mo na kagad bago mo sila pagsama-samahin. Okay? That is problem number 2. Or number 3. Two short shafts having identical diameters of 38.1 mm and rotating at 400 RPM are connected by a flange coupling having 4 bolts. Okay? Tingnan natin. RPM tapos 38.1 ang diameter. With a 100 millimeter bolt circle. The design shearing stress on the bolt is 12 Newton per millimeter squared, 12 MPa. And the design compressive stress of the flange is 15 Newton per millimeter. How thick should be the flange? Yun ang ating hinahanap. Sige lang, okay lang. So, binigay dito yung keyword, short shaft. Okay? Mahanap mo ngayon yung power dyan. Ano ba yung power kapag short shaft? Yung power pag short shaft is d cubed n over 38. Short eh. Okay? Now, you can find na yung ating power. But that is in HP ang lalabas. So, 400 sa n multiplied by d cubed, that should be in inches. So, meron ka dito 38.1. Divide mo na lang ng 25.4 para maging inches. Cube. Okay? Divided by 38. Kaya lang ang lalabas dito in HP. Gawin na natin kagad siyang kilowatt. So, that is 0.746 kilowatt per HP. Okay, solve na natin. 400. Happy talaga. 38.1 divided by 25.4 raised to 3 divided by 38. So, tapusin ko na yung last problem, ha. Point. Magano lang ako. Nebula lang ako. So, that is, store natin yung value sa letter A. Power is in kilowatt na. 26.5 26.5026 kilowatts. That is the power. Ngayon, hahanapin natin yung hindi given. Kailangan natin kasi, para mahanap natin yung thickness, kailangan mo natin given yung mga S niya, anong kailangan natin? Yung torque. Hanapin natin yung torque. Hindi natin alam. Pero yung torque natin kasi, base dito sa formula to, yung power ng pagmumulan. D, N over factor. Okay. Torque, hanapin natin dyan. So, the torque will be equal to power times factor divided by N. Okay, substitute the values. Yung power natin, i-store natin kay A. So, A na lang, multiplied to 9,549,123. Divide by N, that is 400. Ang lalabas dito is Newton millimeter. Pag ginamitan mo ng factor. So, the torque will be, okay, recall natin si A, times 9,549,123. Divide both sides by 400. That is, store natin yung value niya kay B. 632,684.0724 Newton millimeter. So, that is stored sa D. Okay, in-store natin yung value niya kay B. Ngayon, ano nang hahanapin natin? Hahanapin na natin yung bolt circle. Saan natin mahahanap yun? Doon sa shearing stress ng key. Okay? Of the bolt pala, or the bolt. And the shear stress of the bolt, going back, is 12 Newton per millimeter squared. Equal yan sa formula na twice of the torque divided by bolt ang pinag-uusapan, ha, and the number of the bolt multiplied by the area of the bolt. tapos diameter ng bolt squared multiplied to diameter ng bolt circle. Yung bolt circle natin, yun ang hinahanap. Okay? So, pwede na natin ditong solve the diameter ng bolt circle. So, for the diameter of the bolt circle, ibaba na lang natin dito stress ni bolt. Twice nung 632,684.0724 Newton millimeter. Divide natin both sides by the number of the bolts. Ilan ba binigay dyan? 4 bolts. 4 times pi over 4 times the diameter of the bolt. Binigay ba niya? Hindi. Diameter of the bolt pa lang hanapin natin, hindi bolt circle. Binigay pa lang si bolt circle. Ay, ito pala hanapin natin. Diameter of the bolt. So, diameter of the bolt, D bolt, square root natin lahat ito. Tapos, bolt circle, binigay niya is DBC. That is 100 mm. Multiplied by 12 Newton per mm squared. So, Newton, mm. Diameter ng bolt will be square root ng 2 recall ni B over, cancel natin to, 212 times 100 pi. The answer will be 18 point, yung size ng bolt mo, 18.3207 mm. That is diameter ng bolt. Ngayon, ano nga hanapin mo dyan? The thickness. Ngayon, sa compressive stress na ng flange. Galing pa rin naman sa force over area. Ngayon, it will be twice nung torque over yung number of butas times yung diameter ng bolt or ng butas times the bolt circle, DBC, times thickness ng flange. Ngayon, ang hinahanap natin is the thickness of the flange. So, the thickness of the flange is equal to, twice of the torque divided by number of bolt times yung diameter ng bolt times diameter of bolt circle times the stress ng flange. Okay, pwede na nating masolve. Okay, twice ng anong value ni B? Recall natin si B. 632,684.0724 Newton millimeter over number of bolts, so 4 times diameter of the bolt, yung nakalagay doon, ano nga yun? Anong diameter ng bolt? Recall C. Hindi, diameter of the bolt is, sinave ko yan, 18.3207 mm times diameter of bolt circle 100 mm SFL, so that is, check natin, I think 15 Newton per millimeter squared. 15 Newton per mm squared. Cancel si Newton, mm. Matitira na si mm. Okay, so this will be 2. Recall natin si B. Okay, divide by 2 times 18.3207 times 100 times 15. Okay, the answer will be, the thickness is 23.0225 6 mm. almost 1 inch. Okay? Ganun lang. Mahaba talaga siya. May kulang ba ako? Twice. Ayun, hindi pala ganito. Hindi pala 2. That is 4. Ayun, no? This is 4. 11.51. Divide natin ng 2. Okay? Yun. Hindi pala. Mali ako ng pindot. 11.5113 mm. So, that is the answer for number 3. For the last problem, okay, tingnan natin dyan. A flange coupling is to be designed using a 25mm diameter bolt. So, 25mm diameter bolt, diameter of the bolts, at a distance of 152 mm from the center of the shaft, so DBC. Allowable shearing stress on the bolt is 103 MPa. If the shaft transmits 5,800 HP at speed of 1,200 RPM, how many volts are needed? So, makukuha natin si torque. Excuse me. So, mas madali kasi, power is equal to torque N over factor. Ngayon, dito, lahat sila naka-SI units na. So, kailangan si HP ko convert na natin to SI. So, 5,800. Yan, maya na. Factor. Ang hinahanap natin is torque. Torque will be equal to power factor divided by N. Hey, si torque, yung power natin, that is 5,800 HP. Para maging kilowatt, multiply na natin, 0.746 kilowatt per HP. Divided by, multiply po muna natin, 9549000 Newton millimeter divided by N. Ano ba yung N natin? 1,200 RPM. Ang lalabas dito, Newton millimeter. The torque will be equal to 5,800 times 0.746 times 9549123 divided by 1200. Okay, the answer will be 34430,511 Newton millimeter. We will store this value to A. Meron kang torque. Yung torque na yan yung pagmumulan ng ating, ano ba tinatanong? Number of volts. Pag may number of volts, ang binigay sa'yo dyan is the shearing stress. The shearing stress on the bolt is 103 MPa. So, SS, shearing stress on a bolt. Handaan, equal pa rin naman yan sa force over area. Yung force mo is twice of the torque over the affected area. Okay, DBC. Multiplied by the number of the bolt times multiply mo dun sa area of the bolt. That is the affected area. Ang hinahanap natin is the number of the bolt. So, i-simplify na natin. Okay? That is 2 torque over DBC multiplied by 5 over 4 times D ng bolt squared times yung SS ng bolt, shear stress of the bolt. Now, we can solve. Twice of the torque. Ano ba yung torque natin? Copy ko na lang, ha. Yan, gawa ng tamad. Okay? Then, i-divide natin. Ano yung volt circle natin? Pinigay ba dyan? 152. The distance of 152 from the center. So, ang binigay dyan, from the center, ibig sabihin radius yan. Okay? So, ang radius, tandaan nyo, note natin dito, diameter is equal to 2r. So, i-multiply pa natin ng 2. Twice ng 152 mm. Diameter of the bolt, pi over 4. Diameter daw ng bolt mo is 25 mm. Tapos, 103 Newton per millimeter squared. Now, we can solve for the number of the bolts. Okay? So, 2, recall natin si A, divided by 2 times 152 times shift pi over 4 times diameter of the bolt, 25 squared times 103. The answer will be, okay, may nalimutan tayo. 4.48 volts. Ibig sabihin, 4.48 volts. Ibig sabihin, kapag ganito, wala namang 4.48 eh. Approximately 5 volts. Ganyan. Ira-round up mo siya. Okay? Ganun lang ang pag-solve sa flange couplings and keys. So, I hope may naintindihan kayo ngayong araw and I will upload this right away. Okay? Thank you for listening and then stay tuned for the discussion for the space. Bye-bye.